Hey guys, welcome to our Crash Coursable video. This is Chapter 17, Environmental Health Hazards and Human Health. Every day we are faced with a whole bunch of stuff that can kill us. So in this video, we're going to talk about that. Let's go. So, to begin this Crash Coursable video, we're going to ask this question. What major health hazards do we face every day? People face health hazards from biological, chemical, physical, and cultural factors, and from the lifestyle choices that they make. A risk is the probability of suffering harm from a hazard that can cause injury, disease, death, economic loss, or damage. We can suffer harm from 5 types of hazards: chemical, physical, cultural, and lifestyle. What types of biological hazards do we face? In terms of death rates, the most serious infectious diseases are flu, AIDS, diarrheal diseases, malaria, and tuberculosis, or TB, which are the most prevalent in developing countries. Some diseases can spread from one person to another. But in this case, non-transmissible diseases is caused by something other than a living organism and does not spread from one person to another, like cardiovascular, cancer, asthma, diabetes, and last but not least, malnutrition. And as average life expectancy increases, people are more likely to suffer and die from these non-transmissible diseases. So since we're done talking about non-transmissible diseases, let's talk about the next exciting thing: infectious diseases. Okay, so an infectious disease is caused when a pathogen, such as bacterium, virus, or parasite invades the body and multiplies in its cells and tissues, such as flu. Then next is HIV. Following is malaria. Next is TB, or tuberculosis. And last but not least, measles. All of these horrible diseases are transmissible diseases, and they're also called contagious or communicable diseases. In the 1900s, infectious diseases were the #1 killer in the States. Even though the deaths have greatly reduced and life expectancy has gone up, it's still an issue. Pets, livestock, wildlife, insects, food, air, and water all are ways that people can contract and give diseases. Thanks. Well, let's get to some happier things. Epidemics are a large-scale outbreak of an infectious disease in a certain area or country. Well, you really don't want this. A pandemic is really, really, really bad. It's an epidemic at a global scale. The World Health Organization, or WHO, is a developing global atlas who maps stats, i.e. child mortality, and major diseases and stuff like that. But the problem right now is that disease-carrying bacteria have developed a genetic immunity to widely used antibiotics. Viruses evolve quickly, and we can't keep up. And those that aren't affected by these antibiotics anymore kill large numbers of people. And right now, the biggest killer is influenza, or the flu. And following that is HIV, which is human immunodeficiency disorder. HIV infects 2.5 million people annually, and resulting complications from AIDS can and will kill a whopping 2.1 million people annually. This is because HIV attacks the immune system and attacks the T cells, leaving someone with almost zero protection from all these diseases that are wanting to get into them. The thing is, we're trying to fix this, but the people with HIV/AIDS don't have the money. Drugs are, how can I say this? Expensive. I mean, who has cash like that just to throw around? HIV/AIDS is transmitted by unsafe sex, sharing of needles, infected mothers, and exposure to infected blood. In addition to the whole HIV/AIDS thing, some other diseases get a lot of media attention that you better know. So that would be West Nile, syphilis, meningitis, SARS, and everyone knows, Ebola. So the next thing, malaria. It is caused by a parasite in mosquitoes. So the real question is, what is it? I know you're dying to hear that. It infects and destroys red blood cells, causing intense and powerful chills, sweats, anemia, and abdominal pains, headaches, vomiting, and extreme weakness. And about 40% of the world's population lives in areas in which malaria is present, all the way from Central America to Asia. And 1 in every 5 people are at risk. So that means you, and you, all of you, one of you can get malaria. And there's no vaccine. There are preventative actions that we as a people can take. So, we can increase research on tropical diseases and vaccines, reduce poverty, decrease malnutrition, improve drinking water quality, reduce unnecessary use of vaccines, reduce unnecessary use of antibiotics both in people and livestock, education, and we need to make sure that we're clean. Like, we have to require careful hand washing by all medical personnel so needles and infected blood doesn't get stuck in the wrong people. We need to make sure our children get immunizations. We need to provide oral rehydration for diarrhea victims and conduct a global campaign to reduce HIV/AIDS. So, what type of chemical hazards do we face? There's a growing concern about chemicals that can cause birth defects and cancers and disrupt the immune, nervous, and endocrine systems. So, a type of hazard that we deal with are carcinogens. These are chemicals or types of radiation or certain viruses that can cause or promote cancer, like arsenic and benzene, while mutagens are chemicals or forms of radiation that can cause mutation in DNA molecules found in cells. So let's talk about teratogens. These are chemicals that can cause harm or birth defects to a fetus or an embryo, like drinking during pregnancy or doing some angel dust. Offspring that are affected by teratogens usually have low birth weights and developmental problems. So next, we're going to talk about some chemicals that can affect our immune system, nervous system, and endocrine systems. Some natural and synthetic chemicals in the environment called neurotoxins, which can harm us, like PCBs and mercury. And PCBs are a class of 200 plus chlorine-containing organic compounds that are very stable and non-flammable, and they're used in practically everything. While mercury, that also never leaves us and is prevalent in almost everything that we do, is a teratogen and a potent neurotoxin that influences or messes with our nervous system. And it is released into the environment via human resources like coal. So I know everyone's thinking oh my god, mercury, but there are some things that we can do to help keep it down. So we can phase out waste incineration. We can remove mercury from coal before it's burned, convert coal into liquid or gaseous fluid forms to make it better, and we can phase out mercury in batteries and all that jazz. The brain. It's freaking awesome. And one system in the brain is the endocrine system. It is a complex network of glands that release tiny amounts of hormones into the bloodstream. Each of these hormones has a unique shape, but certain chemicals, like mercury, can mimic and block these hormones, which isn't good, and this can wreak havoc in your brain. Estrogen mimics and hormone blockers, aka gender benders, cause effects on sexual development and reproduction. In males, they can, start to become females through feminization, and they could even have smaller penises, lower sperm count, and the presence of male and female organs, which I don't think any of us want. And scientists believe the only solution, or some, is to sharply reduce our use of potential hormone disruptors. Many factors determine the harmful effects of a chemical. Toxicology is the study of harmful effects of chemicals on humans and other organisms, aka the study of poisons. Toxicity is the measure of how harmful a substance is, its ability to cause injury, death, or anything like that, anything harmful to us. Any synthetic or natural chemical can be harmful if ingested in a large enough amount. So, too much water, too much bleach, same thing. Effects of a particular chemical can also depend upon the age of a person who is exposed to it. It can also depend on genetic makeup, which determines an individual's sensitivity to that particular toxin. Another factor is the multiple chemical sensitivity, or how well the body's detoxification system works. Solubility, persistence, biological, and magnification are all the things that make us different in how we handle toxins. And the different ratings of how toxic a substance is super toxic, extremely toxic, very toxic, moderately toxic, slightly toxic, and essentially non-toxic. Should we be concerned about the amounts of various synthetic chemicals in the air, water, food, and in our bodies? Well, we don't know. There's too little data, and it's really difficult to determine the effects of low levels of these chemicals, i.e. birth control. And all these things that we have in our house, like a teddy bear and even fruit, they're smothered in all these synthetic chemicals that just we don't know, and it's perfectly fine right now. That's all we know. Some people have mistaken the idea that all natural chemicals are safe. Mercury, is that really safe? I don't think so. But all synthetic chemicals are harmful, but they tend to forget about medicine. And actually, many synthetic chemicals are quite safe. So, I know you guys are dying to find out how not to die. So, how do we perceive risk, and how can we avoid the worst of them? Well, the most serious ecological and health problems would be like indoor and outdoor air pollution and the chemicals in consumer products. A serious ecological problem would be climate change, and then a medium risk ecological problem would be pesticides, and then a low risk would be oil spills. And the biggest cause of death in the world is poverty, tobacco, flu, air pollution, HIV/AIDS, diarrhea, tuberculosis, automobile accidents, work-related injury and disease, malaria, hepatitis B, and the measles. Most of us are good at assessing the relative risks from hazards that surround us, but most people don't know how to evaluate these risks. And these 5 factors that I'm about to talk about can cause people to see a technology or a product as more risky than the other. This includes fear. So we overestimate something, or we worry about something that's really unrealistic. And then there's degree of control. So you rather drive across the country to all the way to California rather than get on a plane because you're scared that the plane will crash. And then another one will be if it's catastrophic or not. So you might be eaten by a shark, or you might smoke a cigarette, even though a cigarette is more likely to kill you than a shark attack. And then optimism bias is when you're thinking that this doesn't apply to me, like, oh, I won't fall off this cliff, or oh, I'm too cool for that. That will never happen to me. And then instant gratification is when there's a potential harm, but it's later. So you're gonna do it, and it's fun, but then later it might come back and bite you in the butt, like eating ice cream, tanning, or smoking. So I hope you enjoyed this video, and we're gonna go over what we talked about. So we talked about what is a pathogen, non-transmissible diseases, infectious diseases, transmittable diseases, malaria, TB, tuberculosis, HIV/AIDS, PCBs, mercury, BPAs, and its effects, toxicity, dosage levels, and how we react to them, levels of toxicity, and how to evaluate risk and so we can beat death.